Hello, my name is Hawker, and today I'll be going over the basics of Unity. For those who are unaware, Unity is a game engine used to streamline the process of creating games. It allows users to create games on various platforms such as desktop, mobile, console, and more. It's very beneficial for anyone who wants to be involved in game development to have some sort of knowledge on how to use a game engine. There are other game engines to use such as Unreal, but we'll stick to Unity for now. Let's go over some disclaimers before we start. Although this tutorial will focus more on the programming side of Unity, this is not a programming tutorial. I will assume you have some basic C# experience, which is the language Unity uses. You can get away with this tutorial assuming you know other programming languages such as Python or Java, but you'll be looking at the C# documentation a lot. Speaking of documentation, there are a lot of things you can do with Unity. I have been using the engine for 3 years and have only scratched the surface of what the engine is capable of. I recommend doing your own research to see if there's something you're interested in. I find the official Unity documentation a very helpful place to start. I will be using Visual Studio as my IDE. This is not a hard requirement as I know other IDEs such as VS Code are compatible with Unity, but I'm unfamiliar with how to set those up. I am using a Windows device to run Unity and I will be assuming you are as well. If I recall correctly, you can use Unity on Mac and Linux devices, but I don't know how to use those. There is the possibility that something is done differently on those devices compared to Windows. I have slides available in the description below that will be going over the same topics of what this video covers if you're more of a reader. Things are done slightly differently as there are countless ways to do the same thing, but overall the material is the same. I will have the code for my project available on my GitHub, which is also available in the description below. With all that out of the way, we can start with the installation of Unity. Although optional, I highly recommend downloading Unity Hub. It makes managing multiple Unity projects easier. Later versions of the application require a Unity account to be made. Follow the instructions in your browser to create an account. Once your account has been created, press the sign in button in the hub. You should see a page open in your browser saying launching Unity Hub. Now we need to install a specific Unity version. Check the description for a link to all of the Unity versions. I will be using version 22.3.18.f1. The version doesn't really matter, but I recommend using a long-term support or LTS version as those tend to be more stable. When you select a version, you will be asked what modules you want to use. You will need to add Windows build support in whichever module you need for your IDE. For me, that is Microsoft Visual Studio Community 2022. You will need to do this even if you already have Visual Studio installed. I unchecked the box here assuming I didn't need it and got problems later. After you select the version you need, press continue in the bottom right to start the installation. This is going to take a while and may appear to be stuck. My installation took about 10 to 15 minutes, so be patient with yours. Once your installation is finished, press new project in the top right and choose the 2D template. Change your project name and location to whatever you want and press create project. The project is now being generated. This will also take a while to set up, but it shouldn't take as long as the version installation. When your project finishes generating, you should see a window that looks like this. This is your Unity editor. It is where you'll be spending most of your time while developing games. Since we chose a 2D template, everything looks flat, but it's actually a 3D scene in disguise. This can be seen better if you press the 2D button in the top left. Let's go over the controls in this mode. I recommend not using a trackpad and having a mouse with a middle mouse button. It will make navigation a lot easier. You can hold the right mouse button and move the mouse around to rotate the scene camera. Holding Alt with the left mouse button held down will rotate the scene camera based on the center point. Holding the middle mouse button allows you to pan. Holding Alt and the right mouse button allows you to zoom in and out. I recommend taking some time playing with the controls in order to get used to them. You may have noticed I was using the word scene to describe the camera. The camera we are looking through the editor is different from the main camera you see in the left panel. The main camera is the camera that is used in the game. The left panel is called the hierarchy. This is where all objects that are used in the game are held. Currently, we just have our camera. If we click on it, something appears on the right. This is our inspector. It allows us to see more details about the object we currently have selected. It also allows us to change certain aspects of the object. Let's change the position of the camera on its x-axis. This can be done by typing a number in the text box or holding the left mouse button over the X and moving the mouse left and right. You notice that you can go off screen and the mouse will wrap around, so you can go infinitely left or right, which can be very helpful at times. We'll get more into how to modify game objects like this in a bit. Let's look at the play button at the top of the screen. This button allows you to start running the game, also known as being in play mode. I modified my Unity so everything has a purple tint while in this mode. Let's see what happens when I change the position of the camera in play mode. You can exit play mode by pressing the play button again. You'll notice that the camera moved back to its original position. This is because all changes made in play mode are not saved and is why I made my tint an obnoxious color. This can be changed by going to Edit, Preferences, Colors, General, Play Mode Tint. You can change other tints here as well if you like. Let's go over more Unity terminology. You'll notice the word sample scene in the top left. A scene in basic terms is a level that contains everything for a specific section of the game. You can have multiple scenes in a project and switch between them in-game. We will not be going over that today. Instead, we will be using different scenes to create different types of projects. Let's create a new scene called Intro. This can be done by double-clicking into the Scenes folder, right-clicking on an empty space at the bottom, press Create, and then Scene. A new icon will appear at the bottom with the name being highlighted. This is where you can change the name of the scene. If the highlight disappears, you can click on the scene and press F2 to rename it. You can open up the scene by double-clicking it. You will probably get a prompt to save sample scene. Do so if you like. You will know if you have changes in your scene by an asterisk appearing to the right of the scene name. You can press Ctrl S to save your scene changes. Now that we're in a new scene, let's make new objects to interact with. In the hierarchy, right-click, go to 3D Objects, and hit Cube. It looks 2D, but we can see in all its 3D glory by toggling off 2D mode. You'll notice when we look through the game's camera, which can be done by pressing the Game tab at the top, that changing the position of the Z-axis doesn't seem to be doing anything. This is because the main camera's mode is set to orthographic, where the concept of depth is non-existent. When we change it to perspective, we see depth working the same as our eyes do. For the rest of the tutorial, we will be using orthographic mode. We can also have game objects be children of one another. Let's make new game objects by selecting our first one, pressing Ctrl C, and then Ctrl V a few times. We can then drag and drop the duplicates on top of the original. You will notice the duplicates are indented. This means that they are children of the original. This also means the children's coordinates are relative to their parent. If we move the original around, its children will move as well. There is no limit on how many children a game object can have, nor how nested they can be. This is very helpful when you have multiple parts that you want to be considered one object. We can move game objects by sliding the axes around in the inspector, or by holding and moving one of the colored arrows around. Red is the x-axis, green is y, and blue is z. It's easy to tell the positive direction of the x and y, but z can be a bit confusing. The way to know is to remember that Unity uses a left-handed coordinate system. If you hold out your thumbs to the right and your pointer finger up, so you're making two L's, and then point out your middle finger, each middle finger is pointing in different directions. The direction each finger is pointing is the positive direction for that axis for a set coordinate system. In this case, the positive z-axis direction for Unity is towards the screen. It is important to know which coordinate system your application is using in order to make sure objects move and rotate in the correct directions. Speaking of rotating, let's finish up some basic transformations of an object. The hotkey for moving an object around like we've been doing is W. Pressing R will switch to scale mode. You'll notice the arrows turn into squares. You can click and drag one of the directions to scale on that axis, or you can drag the white square in the center to scale all three axes at once. The last transformation is rotation. This can be toggled by pressing E. The squares turn into 3 circles, creating a sphere. Each circle can be held onto any space and moved around to rotate the object. Those are the basics of the Unity editor. Let's move on to how to make scripts, creating our first project. In this project, we will create 2 stopwatch timers, one for incrementing frames and the other for incrementing real-time seconds. Create a new scene called stopwatch and switch to said scene. Create a canvas object by right-clicking on an empty space in the hierarchy, UI, then canvas. The white square in our editor is the canvas. It will contain all UI elements, mainly buttons and text for now. Let's add some text. We want it to be a child of canvas, so we right-click on the canvas, UI, Legacy, Text. Rename the object to something easy to remember like timer. If we zoom out a bit, you can barely see the text because of the color blending in with the background. I'm going to change my color to white, but you can choose any color you want. Color can be changed by using RGB values, hexadecimals, or by using the GUI. For now, I'm going to be using hexadecimals since it's 3 letters. You'll notice it's rather large compared to anything else we've used so far. This is because 1 UI pixel is 1 Unity unit. Although this may seem like we need to either scale up our objects or scale down the canvas, we don't need to do either. If we make a cube and switch to the game view, the objects looks like they have the same size. This is why it's always important to switch between the scene and game view to verify the game looks as desired. The text looks a bit blurry. Let's change that by increasing the font size. As the text gets cut off, increase the width and the height at the top of the inspector. Change the text to be 0 seconds. Now we want a script that will start the timer and change the text. Before we do that, we need to tell Unity which IDE we are using to create scripts. Go to Edit, Preferences, External Tools, then External Script Editor. If you do not see the one you want to use, press Browse and find the exe of the IDE on your device. Going back to the scene, make 2 folders inside the Assets folder called Scripts and Prefabs. We are going to be making a lot of objects, so it's important to be organized. Go into the Scripts folder and make a script called Stopwatch. We will put logic into it later. Then, we want to make a prefab of the timer game object. Do so by dragging the timer from the hierarchy into the prefab folder. We'll see this more later, but prefabs are basically blueprints for when you want duplicates of the same object. For now, double-click on the stopwatch script to open it in your IDE. If you did not download the Visual Studio module in the beginning of the tutorial, you will probably get a warning like this. Go back to Unity Hub and click Installs. Press the settings wheel on the Unity version you are using and press Add Modules. Install the missing module. Once that's done, it will suggest updating your Visual Studio, but that's not necessary. You may get a warning to download a workload called Game Development with Unity. Follow the instructions to do so. If you do not get this warning, you can find the workload through the Visual Studio installer. Click Modify on the Visual Studio version you're using and look for the workload there. If we open the script once more, we won't be getting any errors, but you'll notice the word mono behavior being white when it should be green. The fix for me was to right click where it says Assembly C# in the solution and press Reload Project. Now that we have setup for scripting out of the way, let's go over what Unity gave us. We are given two methods, start and update. Start is called once by Unity after the first frame of the game. Update is called by Unity once every frame. These methods are from the MonoBehavior object that this class is inheriting from. There are several other methods that MonoBehavior have, some of which we will be going over in this video, but most you will need to research on your own. For now, let's log some things in the console. We'll log start1 in start and update in update. It's important to save your work often as crashes sometimes occur and functionality will not change until scripts have been saved. Let's go back to the editor and attach our scripts to our timer game object. This can be done by dragging the script into the timer's inspector. When we hit play and move to the console tab, we'll notice start1 was printed once while update is continuously printed. You can toggle if you want logs to be collapsed in a more digestible way. You can see more information about how well your game is running by pressing stats in the top right while in play mode. The main thing we want to focus on is our FPS. Unity will try to run the game as many frames as your PC can get. This means the amount of update logs that will be printed varies on how good your PC is. We'll get more into that later. For now, let's focus on our timer prefab. We need to update it so it has the stopwatch script. This can be done by selecting the timer object, selecting overrides, and pressing apply all. Prefabs do not need to be updated when modifying a script. However, adding or removing a script, or any other component for that matter, requires updates to the prefab. Let's get back to scripting and look at how to set up breakpoints. You'll notice at the top of our IDE, we have a button called Attach to Unity. Pressing this tells Unity we want to stop when a line with a breakpoint is reached. Let's add 2 more debug lines in start and put a breakpoint on the second line. If we go back to the editor, it will ask us if we want to enable debugging for this session, or for all projects. I don't see a reason why you wouldn't want to have the option to debug, so I would press all projects. After Unity saves your changes, you can enter play mode and notice that the IDE opens and pauses your editor. We won't be able to tab back into the editor, but we can hover over it and see that only start1 printed, which is what we want. Although you can step into the next line, you won't be able to see step 2 printed in the console. Breakpoints are a great tool to see if logic is working the way you expected without relying solely on debug lines. Let's change the text in our timer in the script. We can do this with the use of the method getComponent. GetComponent is a method that can be used to get a specified component from the game object that the script is attached to. In this case, we want to get the text component from our timer object. It returns said component if it is found on the game object, otherwise it returns null. Let's assume the component was found and assign it to the reference timer text. Let's change the text of the timer to be hello. With that working, let's change the text to be whatever we want in real time without needing to open up the script. This can be done by declaring a string with the tag serialized field above it. Then we can change the timer text and update the same way we did in start. Save your changes and go to the editor. If you look in the timer's inspector, you'll see a new text box with the name of the variable we made in the script. When you run play mode and start typing in the box, the text content should match with what you're typing. Serialized field is good for small edits or tweaks that would otherwise be cumbersome to do in the script. Back in the script, let's make a float that will keep track of the time and increment it by 1 in update. We can then change timer text to be this value. You'll notice that it increments fast at the beginning, but then slows down a bit in various places. This is because my frames were dropping a bit, so the update call wasn't happening as frequently. This isn't a good way when you want to do something consistent like keep track of time. Luckily, Unity provides us a float that tells us how much time has passed since the last frame. We can replace that with the incrementing by 1 and change the format of the timer to see up to the second decimal place. Now the timer is being updated in seconds. You should always use delta time when dealing with anything relative to time, including motion over a set interval, which is something we will get into more in the next project. Let's add a boolean in our expector that will tell the timer to use delta time or not. We want to use serialized fields so it's easy to change in the expector during play mode. Now we can add another boolean that tells the timer to stop or continue. The hardest part about this code was apparently trying to use a ternary operator. We can then toggle both these checkboxes to see the script working how we want it to, regardless of the status of the checkboxes. Now we can create a button that will handle toggling if the timer should run or not. Right-click on the canvas object, UI, Legacy, Button, and name the button to whatever you want. The button object does come with a child object that has a text component attached to it. Change the text to say Start. Since we're adding more objects, I decided to refactor the layout of the hierarchy. I made an empty game object and named it the timer. I renamed our prefab to be timer text, and moved that along with our new button to be children of timer. Although the moving and renaming wasn't necessary, it made more sense to me to make it this way. You are allowed to have the layout however you want, but be aware of possible syntax errors, which we will be talking about more later. Let's get back to our script and make a public method that will toggle the start timer boolean we made. We can call this method when the button is clicked by first attaching the game object that has the stopwatch script attached to it, which should be timer text. In order to keep the button's inspector on screen, you can press the lock in the top right corner. Once the object is dragged over, click on the drop down that says no function. Go to stopwatch and select the method we just made. Run play mode and pressing your button should toggle the stopwatch running. We can finish up by changing the button text depending on if it's running. In the script, make a text reference for the button and change the text accordingly using start timer's value. When you run play mode, you will get a null reference exception. If we put a breakpoint on the line we just made, you'll see that button text is null. This is because we never set it. Although this was an obvious error based on the exception name, sometimes it isn't as clear. If you ever confused on why an exception is being thrown, put a breakpoint and go line by line until something doesn't make sense. We know now that we need to set up the button text reference. There are two possible ways of doing this. Neither is necessarily right or wrong. It comes down to preference. I will be showing both ways, and you can decide which way you like for yourself. In the editor, lock timer text inspector, and select the game object that has the text component we want. Drag said game object into the box. When we run the application, no exception should be thrown. We can add the same logic in start so we don't need to press the button to get the correct name. The other way of getting the component is to use getComponent. However, since the component is not on the game object this script is attached to, we will need to use another method. Luckily, we have access to the keyword transform. This variable can do many things, but for right now, we can use transform followed by the parent variable to get the parent of this game object. We can use this in addition to the find method in order to find the child we want, and use getComponent the same way we did before. You'll notice that I use / in the find method. This is because the find method allows you to look for children of children using forward slashes. You can do the same thing with the parent by using 2 periods followed by a forward slash. Why didn't I use that here? I genuinely forgot about it until I started writing this script. This is just another example of how many ways there are to achieve the same goal, which is why I encourage independent exploration. Like I said, both ways work, and it's up to preference in how you get it done. I personally like using Git component as it makes my inspector less cluttered. However, if the structure of the hierarchy changes, the find method will need to be changed as well. Otherwise, you're likely to get no references, which you can see me doing now since I decided to change the format again. I moved the stopwatch script to timer instead of timer text and made it so timer was the prefab instead. This also caused me to set up the on click for the button again. It's very important to test your code even after making small changes because they can have devastating effects such as this. Once there are no more errors, the project is pretty much done. You can make a duplicate of the timer and make it so one does real time and the other does frame count. You'll notice I made it so the prefab always has start timer checked. This can be done by right-clicking on the variable in the inspector and clicking apply to prefab. Again, we'll get into the benefits of having prefabs more in the second project. Run your program once more and make sure it works as intended. Now we can make a build of the application so it can be used by anyone outside of the editor. Go to File and press Build Settings. We want to only have the stopwatch scene we made at the top. Press Add Open Scenes to add it and deselect Sample Scene. Having multiple scenes like this would be used if we were switching between levels, but that is not on the table today. If people are interested in learning more about Unity, I'll consider making another tutorial going over more advanced topics. Let me know in the comments below. Back to the build settings, there are several settings you can change here, such as platform, the resolution of the game, and author credits. I will be focusing on how to change the name of the project for now. I recommend looking into the other settings in your own time. Press Player Settings in the bottom left, go to Player, and you'll see Product Name. This will be the name of your exe when you build the project. Call it whatever you like. You now have the option to build or build and run. Both build the project, but the build and run option runs the application automatically once the build finishes loading. Either option is fine to choose. You will need to tell the application where you want to build it. I usually make a folder called build in the root folder of the project. Wait a few minutes for the build to finish. Once it's done, congratulations, you made your first Unity game. We did not make any buttons to close the project, so we need to press Alt F4 in order to exit it. Now we'll move on to the next project. In this project, we will be controlling the player around the world with keyboard inputs and creating obstacles with our mouse clicks. We will change the color of the player and obstacles when they collide. Since there's a lot more information we're going to go over, I will not be explaining things in depth like I did in the last project. If you need a refresher or are not comfortable with what we went over, rewatch the video to this point and try to make some projects that are the same scale of Project 1. When you feel ready, come back to this video. Start by downloading this template, which can be found in the description. You can copy and paste the content into a text file and then change the file extension to Unity. This scene just has a button set up in a way so it stays in the top left corner of the screen at that scale ratio. I will not go over how I did so, but if you are curious, you can leave a comment and I will try to respond. We're going to first make an obstacle using sprites. Create an image folder the same way you did for the prefabs and scripts. Download this circle image that is found in the description and put it in said folder. Click on the circle and make sure the texture type is sprite. Press apply in the bottom right. Create an empty game object and add a sprite renderer. As the name implies, the sprite renderer component renders sprites. Add the circle sprite to the sprite variable. You can also change the color to whatever you want. It looks a little big. Let's go back to the image and change the pixel per unit, or PPU. The bigger the number, the smaller the object appears. We changed the PPU instead of the scale because scaling the object has a chance of making it more blurry. Be sure to press apply to save your changes. Make the obstacle sprite a prefab and delete it in the hierarchy. We won't need it for a while. Now we need to install a package that will allow us to get player input. Go to Window, then Package Manager. Make sure the drop down in the top left says Unity Registry. Use the search bar to find the input system and press Install. If a warning pops up, press Yes. When Unity restarts, go to Edit, Project Settings, Player, and Other Settings. Change Active Input Handling to Input System Package New. You will probably need to reset again. Go to Edit, Preferences, External Tools, and make sure the top 3 checkboxes are checked and hit Regenerate Project Files. Finally, select the Event System game object in the hierarchy and press the button below the warning in the inspector. We did all those steps in order to set up Unity's new input system and not have it collide with the old one. Instead of going into how the two systems vary, let's move on to creating an input action. In the Assets folder, create an input action, which is probably at the bottom of your Create window. You can call it whatever you want. Open it by double-clicking on it. On the left are where the action maps are. Action maps are a container for button binds to an event. They're good if you plan on having local multiplayer or have different modes. An example being a stealth level in a game having a different configuration to a platforming level. We will be having only one action map here. Call it something like player. Actions are similar to events in which they are fired when a specific input is done. We will create an action called Create Circle. We want Create Circle to be called when the left mouse button is pressed. Create a binding with the path being left mouse button. Turn on autosave and close the player map. Create an empty object called Input Manager. This object will be responsible for anything related to inputs. Create a script called Input Manager and add it to the game object. We will add functionality to it in a bit. Add a component called Player Input. Add the action map we made in the Assets folder. Change behavior to be Invoke Unity Events. Open up the Input Manager script and add Using Unity Engine Input System at the top. We want to create a public function that will handle the code of creating an obstacle when the button is clicked. We return if the context is started or cancelled because we want to call this method only when the left mouse button is initially pressed down. Not having this check will also count when the button is held or let go, causing duplicate triggers to occur. Add a debug line to tell us that the click occurred. In the editor, open the Events dropdown and then the Player dropdown in the Player Input component. You should see a method called Create Circle. Drag the Input Manager game object inside the box. Select the Create Circle method as a function. When you run the game, you should see clicks logged out in the console. Make a sprite renderer variable that will hold the obstacle prefab we made with the serialized field tag. In the Create Circle method, get the mouse position and convert it from screen coordinates to world coordinates. We will then use a function called Instantiate, which will create clones of the prefab at the position we clicked at. You will notice the objects are being created in the hierarchy, but the objects can't be seen. If we click on any of the clones, we'll notice that the Z value of the position is not 0. This is because they are using the main camera's Z value. This is the equivalent of something being just out of your peripheral vision that you can't see it. If we make the Z value 0, then they will be visible to the camera. I made the Z value the same as the Input Manager, the game object, not the script, Z value. In this case, they do the same thing, but if I were to move the Input Manager to be behind the camera, then the obstacles would not be visible. It doesn't matter in this case, but it's something to be mindful of. Let's make a new script called Obstacle Manager. It will keep track of all the obstacles and have the logic of deleting them. Make a list of sprite renderers and use a for each loop to destroy the objects, and then clear the list. We destroy the objects first so we don't lose references to them. Then we clear the list so we don't have no references in their place. We'll put a debug line at the end to verify the method is being called. Make another game object called Obstacle Manager and attach the script we made to it. Attach the clear obstacle method to the button the same way we did before with the stopwatch. You'll notice that the debug line is printed, but the obstacles are still there. This is because we need to have the Input Manager and Obstacle Manager scripts communicate with one another in order to handle cleanup properly. In the Input Manager, make a variable of the Obstacle Manager with the serialized field tag. Get the reference to the prefab that was instantiated and add it to the Obstacle Manager's list of obstacles. Be sure to update the fields in the inspector. Although the obstacles do disappear, they're still in the hierarchy. If we click on the clones, we'll see that they're missing their sprite renderer component. This is because we told the code to delete the component rather than the entire game object itself. Now that we have our obstacles, we can make our player. Download this triangle image in the description and put it in your images folder. Create an empty game object called player with a sprite renderer component. Attach the triangle image you just downloaded to the sprite renderer and change the PPU to your liking. Create a script called player and attach it to the player game object. In the player script, create a vector2 variable called direction. Set it to 0 and start. And update normalize direction, then check if the magnitude is not 0. If it isn't, then have the player rotate into the direction of the vector. The method look rotation may look scary, especially since it derives from the Quaternion class. All you need to know is that the method is causing the head of our player to look in the direction we tell it to. We want to change directions through player's input, specifically through WASD or arrow keys. First, we need to set up the input events through our map. Add an action called move where WASD and the arrow keys match the directions. For the binding, set the composite type to be 2D vector. Save and close the action map. Back in the Input Manager, create a method called onMove that will read and log the context vector2 value. Attach the method to the player input object the same way we did for create circle. When you run the game and hit the keys, a vector should be printed. The first number that is being printed tells us if there is any movement on the x-axis, while the second number tells us if there is any movement on the y-axis. Let's use these numbers to move the player. In the Input Manager script, add a reference to the player. At the end of the onMove method, assign the player's direction to be the direction we got from the keyboard. Again, be sure to assign the player variable in the inspector of the Input Manager. Now we can make it move in the direction we're facing. In the player script, add a vector variable called velocity at the top, and assign it to 0 in start. At the end of update, set it to direction multiplied by delta time. Change the position of the transform to be the sum of the current position and the velocity. When we start holding a key, the player starts moving in that direction, but it's rather slow. We can increase the speed by making a float value at the top and multiplying the velocity by said value before the position is set. Use serialized field in order to set the variable in the inspector to whatever you want. Be sure that is not 0, otherwise you will not move. The only thing left is to add the collision logic. There are two general ways to check for collision: axis aligned bounding boxes, AABB for short, or circle collision. There are pros and cons to both, but since we are dealing with rotation, and one of our objects is a circle, we're going to be using circle collision. The logic is pretty simple. We take the two radii of our two objects, add them together, and if the distance between the two centers of the object is less than the radii sum, then they are colliding. Before we make the logic for collision, we're going to need a radius variable for both our player and obstacle objects. Let's add a float to the player. This is an arbitrary number, but we want it to be as accurate as we can get it. We can use a function called onDrawGizmos in order to show us what the bounding circle would be for the player. Let's first declare the function and log something out. When we run our program, nothing happens. This is because we don't have gizmo on. This can be done by pressing the word gizmo in the top right. Now we know the gizmo is working, we need to draw a circle. First we need to give gizmo a color. Then we can tell it to draw a wire sphere given a position, the center of our object, and a radius, the number we're setting now. We don't even need to run the program to see the circle. We can change the radius to be as accurate as we like. After you're satisfied with the player's radius, make a new script called obstacle. Add the obstacle prefab we made back into the hierarchy and add the script. You want to make the radius the same way we did with the player. Once you are satisfied with the obstacle radius, open your obstacle manager script and replace all instances of sprite renderer with obstacle. The same needs to be done with the prefab and input manager. This means you will need to update the references in the hierarchy. After testing everything works, we can move on to the collision code. Create a new script called collision manager. Here we can write a generic method called circle collision that says if two objects are colliding. The code itself isn't difficult, especially since Unity has a distance method that does the math for you. However, I will not be using it as it uses square root, which is computationally heavy. This means overuse of it can cause performance issues. It may not be an issue for this project, but it's important to practice good habits early. Since we are now calculating the square of the distance, we need to check if that is less than the square of the sum of the radii. We can now use this function to create a method in order to see if the player is colliding with a specific obstacle. In the update function, we can use this method to see if the player is colliding with any obstacles using a for each loop. Let's print a log to see if we did this correctly. Seems to be working fine. Let's change the color of the sprite on collision. When they are colliding, we set them both to red. Otherwise, we change them back to their original colors. I'm setting a color variable for the original obstacle color, which can be changed in the inspector. Be sure that the alpha level is not 0, otherwise it will appear transparent. When we run the program, we notice something interesting going on. It seems that the player is not changing colors for any of the obstacles except the last one in the list. This is an intentional oversight that I left in for you to figure out on your own. I have already given a big hint. I recommend using the debugger and using a small list of obstacles, no bigger than 3, to figure it out. If you are stuck, the solution will be on my GitHub. I highly suggest that you try this on your own for a few minutes before looking up the answer. Critical thinking is a crucial skill to have as a game developer. Once you figure it out, you're done with this tutorial. Again, I have only scratched the surface of what Unity is capable of. I highly recommend looking at the Unity documentation to see what else the engine can do. You can even go back through the video and tell me what I could have done differently. With that being said, I am planning to do more things on this channel, mainly things related to coding and software development, engineering, game design, all that. Let me know if you want to see something specific. I'm planning to mainly show personal projects that I have some interest in, or maybe puzzle solvers. My throat hurts so much, so I'm ending the video here. Thank you for watching. Goodbye.